The shattering of replacement glass in a halogen light can be attributed to several factors. Firstly, thermal expansion differences between the replacement glass and the original factory glass can be a significant cause. When the light is activated, the heat generated by the bulb causes the glass to expand. If the replacement glass has a different expansion coefficient than the surrounding metal housing or even the original glass, this differential expansion creates stress. This stress accumulates and can eventually exceed the glass's tensile strength, leading to breakage. Secondly, stress concentration can play a role. The edges of the cut glass, especially if cut without precision or proper tools, may contain micro cracks or imperfections. These imperfections act as stress concentrators. Under thermal stress, these tiny cracks propagate, weakening the glass and causing it to shatter, often at the weakest point along the edge. Thirdly, contamination is another possible factor. If the replacement glass was not thoroughly cleaned before installation, impurities or debris on its surface can act as nucleation sites for cracks. These impurities disrupt the glass's uniform structure, making it more susceptible to cracking when subjected to thermal stress. Even microscopic particles can initiate crack formation. Fourthly, incorrect mounting can contribute to glass shattering. If the replacement glass isn't properly seated or secured within the light fixture, it may be subjected to excessive pressure or vibration. This mechanical stress, combined with thermal stress, can significantly increase the likelihood of breakage. Over-tightening screws or using improper mounting hardware can exacerbate this issue. It is important to adhere to several key lessons. Firstly, it's crucial to follow UL listings. UL, which stands for Underwriters Laboratories, listings signify that the equipment has undergone testing and meets established safety standards. Tampering with UL-listed equipment, such as modifying the light fixture with non-approved parts, can void the warranty and, more importantly, significantly increase the risk of accidents, including fire hazards. Secondly, always use heat-resistant glass specifically designed for lighting fixtures. Regular glass, which may appear similar, is not formulated to withstand the intense heat generated by halogen bulbs. Heat-resistant glass, often borosilicate glass, has a lower coefficient of thermal expansion and higher thermal shock resistance. Thirdly, proper installation is paramount. Ensure that the replacement glass is correctly mounted and secured according to the manufacturer's instructions. This includes using the correct mounting hardware, avoiding over-tightening, and ensuring a snug, but not force, fit. In this specific scenario, consider these recommendations. Purchasing a replacement glass lens directly from the manufacturer is the best course of action. This ensures compatibility with the light fixture and guarantees that the glass is specifically designed to withstand the heat generated by the bulb. Using a generic piece of cut glass introduces uncertainty regarding its thermal properties and structural integrity. Consulting with or hiring a qualified electrician to install the new lens is advisable. An electrician has the expertise and experience to properly mount the glass, ensuring it is secure and minimizing the risk of improper installation. This is especially important if you are unfamiliar with electrical work or the specific requirements of the light fixture. It is also helpful to regularly check the light fixture for any signs of damage or overheating. Inspect the lens for cracks, chips, or discoloration. Also, check the surrounding housing for signs of melting or deformation. If you notice any of these issues, immediately turn off the light and investigate the cause. Overheating can indicate a problem with the bulb, wiring, or ballast, and should be addressed promptly to prevent further damage or hazards. Choosing the correct type of glass for high-temperature applications involves understanding the properties of different glass materials and their suitability for specific conditions. Regular or soda-lime glass is the most common and least expensive type of glass. It is used for windows, bottles, and other everyday applications. However, it has a relatively high coefficient of thermal expansion and poor thermal shock resistance, making it unsuitable for high-temperature applications where sudden temperature changes are expected. Borosilicate glass, such as Pyrex, is known for its excellent thermal shock resistance and low coefficient of thermal expansion. It can withstand rapid temperature changes without cracking, making it ideal for laboratory glassware, ovenware, and some lighting applications. Fused quartz or fused silica glass has the highest thermal shock resistance and lowest coefficient of thermal expansion of all common glass types. It can withstand extremely high temperatures and rapid temperature changes without failure. It is used in high-temperature furnace windows, crucibles, and other demanding applications. Aluminous silicate glass is another type of high-temperature glass with good chemical resistance and mechanical strength. It is often used in applications where both high temperature and corrosive environments are present. When selecting glass for high-temperature applications, consider the following factors. The maximum operating temperature the glass will be exposed to is important. Exceeding the glass's temperature limit can lead to softening, deformation, or failure. Also consider the rate of temperature change the glass will experience. Rapid temperature changes can cause thermal shock, especially in glasses with high coefficients of thermal expansion. Chemical compatibility is also key. If the glass will be exposed to corrosive chemicals, select a glass type with good chemical resistance. The mechanical strength of the glass must be sufficient to withstand any applied stresses, including pressure, vibration, or impact. The optical properties of the glass may be important for certain applications, such as windows or lenses. For lighting fixtures, especially those using halogen or other high-intensity bulbs, borosilicate glass is generally the preferred choice. It offers a good balance of thermal shock resistance, temperature resistance, and cost-effectiveness. Ensure that the replacement glass is specifically designed for lighting applications and meets the manufacturer's specifications. Understanding the role of underwriters' laboratories in product safety and certification is also important. UL is a global safety certification company. It tests and certifies products to ensure they meet established safety standards. UL certification indicates that a product has been tested and evaluated to minimize the risk of fire, electric shock, and other hazards. UL develops safety standards for a wide range of products, including electrical appliances, lighting fixtures, electronic devices, and building materials. These standards are based on extensive research, testing, and industry best practices. When a product is submitted for UL certification, UL engineers conduct rigorous testing to evaluate its safety performance. This testing may include electrical safety tests, fire resistance tests, mechanical strength tests, and environmental tests. If the product meets the requirements of the applicable UL standard, it is granted UL certification and can display the UL mark. The UL mark is a widely recognized symbol of product safety and compliance. It indicates that the product has been independently tested and certified to meet UL safety standards. There are different types of UL marks, depending on the type of product and the scope of certification. The most common UL mark is the listed mark, which indicates that the product has been evaluated for safety risks. The recognized component mark is used for components that are intended to be used in other UL certified products. The classified mark is used for products that have been evaluated for specific properties or characteristics such as fire resistance or energy efficiency. UL certification is not mandatory for all products, but it is often required by retailers, insurance companies, and regulatory agencies. Many consumers also prefer to purchase UL certified products as it provides assurance of safety and quality. When purchasing electrical or electronic products, always look for the UL mark to ensure that they have been tested and certified to meet safety standards. Modifying UL-listed equipment can void the warranty and potentially create safety hazards. If you need to repair or modify a UL-listed product, use only approved replacement parts and follow the manufacturer's instructions. Consulting with a qualified electrician is always a good idea when dealing with electrical equipment. They can ensure that the equipment is installed and maintained safely and in accordance with applicable codes and regulations. Halogen lamps operate at very high temperatures, which can pose a fire hazard if not properly managed. The high temperatures are due to the principle of operation of a halogen lamp. Halogen lamps are a type of incandescent lamp that uses a tungsten filament surrounded by a small amount of halogen gas, such as iodine or bromine. The halogen gas helps to regenerate the tungsten filament, extending its lifespan and allowing it to operate at high temperatures. The regeneration process works as follows. As the tungsten filament heats up, tungsten atoms evaporate from the surface. These tungsten atoms would normally deposit on the inner surface of the bulb, causing it to darken and reducing the light output. However, in a halogen lamp, the evaporated tungsten atoms react with the halogen gas to form tungsten halide molecules. These tungsten halide molecules circulate within the bulb until they come into contact with the hot filament. The high temperature of the filament causes the tungsten halide molecules to break down, releasing the tungsten atoms back onto the filament. This process effectively redeposits the tungsten atoms onto the filament, preventing the bulb from darkening and extending its lifespan. Because the tungsten filament is constantly being regenerated, it can be operated at a much higher temperature than in a traditional incandescent lamp. This higher temperature results in a whiter, brighter light and a higher luminous efficacy, which is the amount of light produced per unit of energy consumed. However, the high operating temperature also means that halogen lamps generate a significant amount of heat. The surface temperature of a halogen bulb can reach several hundred degrees Celsius, which is hot enough to ignite flammable materials. Therefore, it is important to take precautions when using halogen lamps to prevent fire hazards. Firstly, never place halogen lamps near flammable materials such as curtains, paper, or clothing. Maintain a safe distance between the lamp and any combustible materials. Secondly, use halogen lamps only in fixtures that are specifically designed for them. These fixtures are typically made of heat-resistant materials and have ventilation to dissipate the heat. Thirdly, never leave halogen lamps unattended when they are turned on. Always turn them off when you leave the room or go to sleep. Fourthly, replace halogen bulbs with the correct type and wattage. Using a bulb with a higher wattage than the fixture is designed for can cause it to overheat and potentially start a fire. Fifthly, if a halogen bulb breaks, clean up the broken glass carefully. Wear gloves to protect your hands and dispose of the glass in a sealed container. Some halogen bulbs contain mercury, so it is important to follow proper disposal procedures. The type of glass used in halogen lamps is typically a hard glass that can withstand high temperatures. The glass is also treated to block ultraviolet radiation, which can be harmful to the eyes and skin. While the glass itself is heat resistant, it can still become very hot to the touch when the lamp is operating. Therefore, it is important to avoid touching the bulb when it is turned on or has recently been turned off. Always allow the bulb to cool completely before handling it. The use of a motion sensor with a halogen lamp can also affect the bulb's lifespan. Frequent switching on and off can shorten the lifespan of the bulb. However, modern halogen lamps are designed to withstand frequent switching. If you are using a motion sensor with a halogen lamp, choose a lamp that is specifically designed for this type of application. These lamps typically have a more robust filament and a longer lifespan. The wiring used to connect a halogen lamp must be appropriately sized for the lamp's wattage and voltage. Use wiring that is rated for the maximum current draw of the lamp. If the wiring is too small, it can overheat and potentially start a fire. Also, ensure that the wiring connections are secure and that there are no loose wires. Loose wiring can cause arcing, which can also lead to a fire. When installing a halogen lamp, follow all applicable electrical codes and regulations. If you are not comfortable working with electricity, hire a qualified electrician to do the installation. An electrician can ensure that the lamp is installed safely and correctly. Regular inspection of the halogen lamp and its fixture is important to identify any potential problems before they become hazards. Check the bulb for cracks or damage. Check the wiring for fraying or loose connections. Check the fixture for signs of overheating or damage. If you notice any problems, repair them promptly. Considering LED alternatives for motion sensing lights could also reduce fire risks. LED lights are much more energy efficient than halogen lamps and they generate much less heat. This makes them a safer option for motion sensing lights, which are often used in areas where there is a risk of fire, such as near flammable materials. LED lights also have a much longer lifespan than halogen lamps, which means that you will not have to replace them as often. This can save you money in the long run. When choosing an LED light for a motion sensing application, look for one that is specifically designed for this type of use. These lights typically have a wide detection range and a fast response time. They are also designed to withstand frequent switching on and off. The color temperature of the LED light can also affect its performance. Choose a color temperature that is appropriate for the application. For example, a warm white light is often preferred for residential applications, while a cool white light is often preferred for commercial applications. The brightness of the LED light should also be considered. Choose a light that is bright enough to provide adequate illumination, but not so bright that it is blinding. The installation of an LED light is similar to that of a halogen lamp. Follow all applicable electrical codes and regulations. If you are not comfortable working with electricity, hire a qualified electrician to do the installation. Regular maintenance of the LED light is also important. Clean the lens of the light regularly to ensure that it is providing optimal illumination. Check the wiring for any signs of damage. If you notice any problems, repair them promptly. Motion sensor technology has evolved significantly over the years. Early motion sensors use passive infrared PIR technology to detect movement. PIR sensors detect changes in infrared radiation caused by the movement of warm objects, such as people or animals. PIR sensors are relatively inexpensive and reliable, but they can be prone to false alarms caused by changes in ambient temperature or sunlight. More recent motion sensors use microwave technology to detect movement. Microwave sensors emit a low-energy microwave signal and detect changes in the reflected signal caused by the movement of objects. Microwave sensors are more sensitive than PIR sensors and are less prone to false alarms. However, they are also more expensive. Some motion sensors combine both PIR and microwave technology to provide even more accurate detection. These sensors use PIR technology to detect movement and then use microwave technology to confirm the presence of an object. This reduces the risk of false alarms caused by changes in ambient temperature or sunlight. The range of a motion sensor is the distance over which it can detect movement. The range of a motion sensor depends on the technology used and the sensitivity of the sensor. PIR sensors typically have a range of up to 50 feet, while microwave sensors can have a range of up to 100 feet. The sensitivity of a motion sensor can be adjusted to suit the application. A more sensitive sensor will detect smaller movements, while a less sensitive sensor will only detect larger movements. Adjusting the sensitivity of a motion sensor can help to reduce the risk of false alarms. The detection angle of a motion sensor is the angle over which it can detect movement. The detection angle of a motion sensor depends on the design of the sensor. Some motion sensors have a wide detection angle, while others have a narrow detection angle. Choose a motion sensor with a detection angle that is appropriate for the application. The response time of a motion sensor is the amount of time it takes to detect movement and turn on the light. The response time of a motion sensor depends on the technology used and the design of the sensor. Some motion sensors have a very fast response time, while others have a slower response time. Choose a motion sensor with a response time that is appropriate for the application.